So again, after SQ3 are in your lesson 2.1 on your own, you should hopefully, one of the biggest hangups for students is being able to read those inequality symbols properly and being able to set them up in statements properly so that they really show the relationship correctly. So let's first of all talk about what are inequalities. An inequality is a statement that compares two expressions. We know what an expression is. It can be numeric or it can be algebraic. We have two expressions, and it uses one of the 5 symbols that are here. So looks like I have to calibrate here quick. So when we have a kind of looks like a V lying on its side, pointing to the left, what does that inequality symbol? What words can we replace? What should we say when we're reading that in a mathematical statement with that inequality symbol in it? So this first one, it's like a V lying on its side pointing left. What does that one say? Riley?
Less than.
Pardon?
Less than.
Not just less than. Macy?
Less than equal to?
No, not less than or equal to. Oh, let's look at our books then. Let's look at our SQ3R somewhere where there's just one little thing missing there that you're not saying, Riley. Is. It's really important that we use the word is. Because remember, just the words less than means subtraction. So when we see the words less than, that does not mean the same thing. That means you're going to do a subtraction. This, we would say, is less than. We have to make sure we include that word is in there. Okay, just like we say is equal to, this one we're saying is less than. Okay, how about the one that's right under it then? What does that one say? Go ahead, someone offer up. Tate?
It's not a solution.
This one right here. No. Austin?
It's less than or equal to.
Okay, is less than. We have to use the word is again. So the is less than symbol is there, but then also is that little bar underneath it. So that says or equal to. It doesn't. Here we don't have to use the word is because we already used it at the beginning. Is less than or equal to. In other words, it has to satisfy one condition or the other. It doesn't have to satisfy both. Okay, how about our next one? Now we have that V lying on its side, pointing to the right. What's that one tell us? Austin? Is greater than. Remember, we have to use the word is again, because if we just use the words greater than, that means what? What does greater than mean? Addition, yeah. So we have to make sure we include that word is. Well, then the next one would be, since it's the same inequality symbol, but now with a bar under it, it would be is greater than or equal to, yeah. So it has to satisfy one of the conditions or the other. And then our very last one, Colin, what's that one?
No solution.
No, it's not no solution. Avery? Is not equal to. We have a different symbol for no solution. This one does not mean no solution. It might, if we end up with a relationship like this when we're solving an equation, it leads us to say there's no solution. But this is actually saying, okay, this expression is not equal to that expression. Okay. So a solution of an inequality is any value of the variable. So inequalities have an infinite number of solutions. An infinite number of solutions. We cannot begin to name them all. That's why we use the inequality symbol. So any value for the variable that makes the inequality true, just like an equation, when you find the value or values that make the equation true, it's a solution. Same thing here. A solution of an inequality is any value that makes the inequality true. So let's describe what this solution set is saying. These solution sets are saying. So describe the values for the variable that make the inequality true and show the solution on a number line. Okay, what is this first one saying? Read that to me. What does that say? Number 1. Monica, what's that say?
X is less than 10.
Okay, so that's what we're going to write first of all. Well, no, we're not going to write that. We're going to say that really means that instead of x, we're going to say what numbers can be x be? So this is saying x has to be less than 10. It has to, x is less than 10. So that says all real numbers, we're going to describe the solution set, all real numbers, well right now that, if we stop right there, that's saying the whole number line, but it's not the whole number line, is it? It's just all real numbers less than 10. Now, you might be a little bit confused and say, you just said we had to use the word is. Otherwise it means subtraction. Now here we're describing a set of numbers. Here we're describing a set of numbers that this inequality is describing. It is describing all real numbers, any number on the number line less than 10. So is 10 included? No. It's got to be equal to if 10 was included, right? Now, what would be the first number that would be in that set? Anybody think they know? Pardon? 1. So I'm kind of saying like first number less than 10. 9? Well, what about 9.9? It's not a real number? Why not?
Because it's a decimal.
Oh, because it's a decimal. So decimals aren't real?
No.
Oh. So when you tell somebody you have $4.58, the 58 cents isn't real, just the $4?
No.
So on the number line, only the integers, only those are the real numbers. No, there's a whole bunch of other numbers that are there. Decimals are real numbers. Fractions are real numbers. Those guys are all real numbers. So what is the first real number that is less than 10? Can you name it? 9.9? Okay, what about 9.99? How about 9.999? How about 9.99999999999999999? Can you name the first number less than 10? No. It's like you can't. But so what we're saying is it's right up to 10, can't be 10, and there's an infinite number. There are so many numbers. It could be just between 9 and 10 alone. There's so many numbers it could be. But then it's also any other number that is, less than 9, and it just goes on forever and ever. So how are we going to show that on a graph on a number line? Here's what we're going to do. I'm going to make this fairly painless, okay? But you have to at least do this much for me, or I'm going to make it more painful, okay? The starting point, like where we're at on the number line is at 10. Is 10 included though? No. So instead of putting a shaded in circle at it, putting a point there saying 10 is a solution, we have to leave it open. We have to leave it open saying, you know what, this guy isn't included. And then we're going to show the integer values, even though decimals and fractions are real numbers. I'm going to make you show the integer values, the immediate neighbors to the right, the immediate integer neighbor to the right, which is what, by the way? 11. And the immediate integer neighbor to the left, which is 9. And the only reason I'm making you do this is because I want you to have some sort of a snapshot of the number line, that we have something to look at. And you have to show me you have good number line sense. So in other words, the distance between these guys should also be pretty equal. We don't have to take out a ruler and measure it, but the distance between them should be pretty equal. And then which way would we shade on the number line to show all real numbers less than 10? Yeah, to the left, we would shade this way. So include the arrow at the end, because that arrow at the end shows it goes on forever and ever into negative territory and beyond. I mean, it just keeps going. Okay, so that's how you're going to show me. You don't have to show me, lots of numbers on the number line. You're going to show me where is the point it kind of begins, and is that included or not. And then integer neighbor to the left, integer neighbor to the right, showing good number line sense. Anybody have any questions? Okay, this one, what does this one say? The solution set is what? all real numbers. So y is what we're saying. Y can be all real numbers, what?
Greater than or equal to.
Yeah, greater than or equal to, greater than or equal to. And yes, we are writing these out in just full-fledged words. We can do this. All real numbers greater than or equal to -3. Any solution is from this set. All real numbers greater than or equal to -3. Okay, well then what will that look like on a number line? And then kind of like in the middle of our snapshot, what will we have? Okay? Shortcut.
Yeah. Yeah, it's more than 7.
Huh. What's going to be kind of in the middle of our snapshot of our number line here? 0? Should we put 0? -3, yeah. We're just going to, we don't need, 0 doesn't have to be in our snapshot. What's the integer neighbor to the right of -3? -4? -2. This is where you're showing me good number line sense. It's -2. I almost wrote -4. Hayden almost convinced me.
Sorry.
And then what is the integer neighbor to the left? -4, about the same distance from -3. Okay? Well, we are going to, -3 is kind of like our starting point. Is -3 included in the solution set?
Yeah.
Yes, because it says or equal to, oops, I kind of forgot the word TO there, or equal to -3, so we shade that in. And then which numbers on that number line are greater than -3? To the left or to the right? To the right. Now you cannot change the direction of the number line. The number line has one direction. Negative numbers are to the left, positive numbers are to the right, and is less than heads left, is greater than heads right. Don't be trying to change that, okay? Okay, and our last one that we'll practice here together. This one says -3/4 what?
Less than M.
Is less than M. So that means M can be all real numbers.
So -3/4 is less than.
Yeah, but we want to start it out by saying all real numbers. So since we want to start it out with saying all real numbers, how are we going to say that one? All real numbers. So in other words, M is representing all real numbers.
So will we flip-flop this is greater
Can we flip-flop this?
Yeah.
Can this be rewritten like this? Does it mean the same thing? Yeah, it does. So we can reverse, basically everything just kind of turns over. So M is greater than -3/4. Well, now that makes it easier to state as all real numbers greater than -3/4. Okay, what's kind of like the middle of our number line here?
than.
-3/4. Okay. Integer neighbor to the, listen to me carefully now. Integer neighbor to the right.
-2/4.
No,
-1/2.
integer. 0. Thank you. 0. Okay, now, I'm going to put 0, like a little ways away here. What's the integer neighbor to the right? -1. Do I put -1 as far away as I did 0?
No.
No, because the distance that we are representing here is how much distance? From -3/4 to 0, how much distance is represented there? From -3/4 to 0 is 1/4? Distance. Distance, 3/4 of a unit. It's distance. Well then, when you say -1, can I come over here and put -1 here and say I have good number line sense? No. Because now I'm saying that is this is really a distance of how much? 1/4, but it looks like it's a distance of 3/4. I can't do that, can I? So I'm going to mark that wrong on assessments. So when you're, when you're bad-mouthing me in the halls because you're like, oh, she's so fussy and she's so, God, she just barks things wrong for ridiculous reasons. And I'll be like, oh, sorry.
What?
So in other words, your distance has to be represented properly on here. And what kind of a circle are we going to put it -3/4? An open one, or are we going to shade it in?
Open.
Open, and then which direction are we going to shade from there? What are all the real numbers greater than -3/4? In the direction of 0 or in the direction of -1?
Direction 0.
In the direction of 0, yeah. You got to go this way. Now let's just see if we did that right. Kind of go back to here and let's see what this says. This says -3/4 is less than all the numbers m can be. -3/4 is less than all the numbers m can be. Because this is like m right here, you guys. So does that what it says? -3/4 is less than all the numbers n can be.
Yes.
Yeah. So again, we have to be able to set up the relationship properly. If it means renaming the inequality, then rename it, okay? Anybody have any questions on any of those? Yes, Hayden?
Do we have to write?
Yes, we have to write all real numbers greater than, less than.
Okay.
The only thing you get out of writing the word for is the numeral itself, the number itself, okay? I had a feeling that's what the question was going to be. Write the inequality shown by each graph. It looks like you need to look over to page 103 to be able to do this. So now we're going to be showing the graph, and we are going to write the solution, the inequality statement that shows that solution. So number 10. And we get to pick and use any variable we want. Right, so which variable do you want to use this first time? And what? Okay, well then, it's m what?
M.
What is that graph showing? You know what, let's do this because these are notes and we don't have our books open at that point. So let's actually draw what that graph looks like in our notes here. Just so, you know, we won't make it as detailed as they did. Okay, what's the number in the middle?
0. Just kidding, 2. -2.
Okay, and then we would put -1 here and -3 here, and what kind of a circle is that -2?
It's a solid.
A solid circle, okay. And then what direction is it shaded? Left or right? Left, okay. So let's just, you know, it's better in our notes to show, well, what does it look like? What are we writing the inequality statement for? So now, because, you know, the louder people said they want M, go ahead and write something down, and then you can compare with mine and see if you agree. Write your own inequality statement. Okay, do you agree with me? Because what does that say? What is it? It says m is less than or equal to -2. So if you don't have those memorized yet, you better figure out a way to make it happen. Hayden?
I thought we were supposed to write out sentence.
No, this one it says write the inequality. So this is what we're doing. This is an inequality. Okay? This one we don't have to write it out in words. We don't have to describe it. That's when we have to describe, we write it out in words. Okay, our next one, they may not have it drawn like this, but let's draw it like we would probably do it. We would have 8.5, is it a -8.5? Okay, -8.5. Over here we would have a -8. Over here we would have a -9. And it is an open circle, and it is shaded to the right. So, what is that inequality? That one. Not m greater than, that would tell me to put an addition sign.
Is.
M is greater than, and would we have a equal to bar underneath our is greater than? No, because why?
It's not colored.
Because it's not shaded in, it's not included in the solution set, is it? Okay.
It's not so.
Okay, you go ahead and finish the last four. Do it, you know, draw, you can redraw their graph the way I'm gonna make you show it. And then write the inequality statement that would go with it. And then we will compare answers. Okay, enough. Remember, you're practicing how I'm going to have you show number one graphs. I'm not going to make you make it as detailed as the book does. And until you defy even doing what I want you to do, then we'll go to the book's way. You and I should both be able to tell on those graphs whether the endpoint is a shaded in circle or an open circle. No guessing. Should be able to tell which side of that endpoint is shaded. No guessing. Okay, I'm gonna still some papers and take your answers. Oh, some people are at least pretending that they're so ready, so I won't take their paper. It's always good to have people who don't do it right, because then we, oopsie, I'm sorry, that's not a K, that's an A. Okay. Hey, anything we need to challenge up here, or we go with it?
No.
So number 12, should we challenge number 12?
No.
No, you like that one? Okay, how about 13? Should we challenge number 13? Okay, so it could be written out in words, M is less than -7, but what do we need to write? The inequality statement. So this does say, whatever our variable is, it has to be less than -7. So we have to instead then change that into an inequality statement. So should it look like this? Like that? Like that? Okay, no challenge there. Okay, how about number 14? Any challenge there? 15.
No.
Okay, good. Now remember, you get to pick your own variables. So some people stuck with M, some, veered off and said, I want a Y, I want an A, whatever. You get to pick your own. So again, it's going to be really important that you understand which direction it should be, you know, which inequality symbol to use, which direction. You can't say, well, that's what I meant. No, we have to make sure we understand right away from the beginning which sign should we be using, which symbol should we be using. Anybody have any questions? Okay, then let's move on to doing numbers 16 and 17 on this page. Okay, so first of all, read number 16 to yourself. We have to write, looks like our directions are to define a variable, write an inequality for the situation, and graph it. Okay, so the first thing we do is describe what our variable is representing in the situation. What's our variable going to represent in this one? Whoever wants to share that gets to pick the variable also. Okay, Kate?
Club members.
Okay, just club members. Is that enough information? Well, what do you think? Is it enough information? Club members.
20 club members.
Now read it again. That's not enough information
There must
for
be
me.
at
That
least-
doesn't tell me
At
enough.
least 20 club members.
Okay, well, that's going to help us write the inequalities.
Club members in order to hold the whole team.
Okay, so can we shorten that up somehow, Ben?
Club members present.
That's all we have to say. Club members present, right? Okay, so what variable do you want to choose, Tate?
P. Z.
Z. Z is club members present. We can't just say club members. We can't, say anything about how many. We just need to say what is our variable, that solution that we're going to show, and that inequality, whether it's in inequality form or graph form, what is that Z representing in it? Okay? So now we would say Z, what? What would our inequality statement be? Riley? Z is greater than or equal to 20, because it said there has to be what? At least 20, so 20 or more, right? That's what at least means here. So Z is 20, at least 20, so it's greater than or equal to. But we have to be careful here. We also have to describe what is going on as far as these are club members. If we would make the graph the way we typically do, let's just start the graph, okay? What's going to be our number in the middle? 20. Okay. What's the integer neighbor to the right? 21. What's the integer neighbor to the left? 19. Okay. Well, now, if we would we shade in our circle at 20? So 20 club members, that's like included. That satisfies it. Okay. If I would shade it like this, like we typically would do, what would that tell me? Well, tell me there could be 20 or more, but here's what else it could tell me. How about this guy right here? Can you have part of a person, really? No. So we need to go back up here and say where Z is a whole number. We have to kind of like define it. We have to say, you know what? You can't get, you can't just say any real number 20 or more, because that includes like 20.2, that includes 20.99999. You know what? You can't have those. We don't want to talk about parts of people. So where Z is a whole number, and then on the graph, same thing. We're not going to show it as parts of people. We're going to show it as, you know what? Here's what's going to happen. You can have 20, you can have 21, and then you're going to shade your arrow, and that shows it keeps going in this direction in that pattern. It keeps going up by 1, not in between those numbers. Okay, so we have to be a little more careful when we know what our variable is representing. We can't just say, you know what, good enough. Okay, go ahead now and try 17. Read that one. And let's decide what should our variable represent in this one. Okay, what's the unknown in this? Chase?
Beats per minute.
Beats per minute, okay. So what's the variable you want to choose? R, okay. R is, I'm guessing they're talking about a heart rate, right? So is heart rate in beats per minute? Okay, so beats per minute of what? Well, it's your heart rate, okay. Well then, what inequality would we write to describe what this is saying? We got this R, we would start with R. What does it say? Riley? R is less than 140. Okay, so how did it state it? That we know to use is less than. What did they say? Chase? Under 140. So is 140 included in the under? No, it can't be. If it says under 140, if it said 140 or under, then we would include it, wouldn't we? And then we'd have to put the equal to bar there. Now, again, let's start graphing this and see what happens. If we have 140, before we even put the integer neighbors, I want to know, do you think there is, and which direction are we going to go, by the way, when we shade? Are we going to go right or left? We're going to go left, aren't we? Do you think there's ever a stopping point? Or do you think any real number less than 140 qualifies? They better stop or what?
He's dead.
Or you're dead, yeah. Or you're dead. When would you be dead?
0 heartbeats.
When there's no heartbeat. I mean, and probably even before that, but for sure at 0 heartbeat, beats per minute, would you even be alive anymore? No. So we are going to only go down to 0. We're not going to do integer neighbors this time. We're going to do from 0 to 140. And 140 doesn't count because it said under 140. 0 doesn't count because, why? Because you got to be alive. And so anything in between. Can you have parts of heartbeats per minute, by the way? Do they have to be whole numbers? No, you can have like maybe 138 and a half beats per minute. But we do have to, so here's how we're going to define what we just discovered on the graph. Where R is what kind of a number? What's this?
Any number.
Well, no, we don't even have to do that. What kind of a number is it?
Whole number.
It doesn't have to be a whole number this time.
All real numbers.
No, it doesn't. It's not all real numbers. Where R is a positive number. In other words, that's what helped us make this graph. We said, you know what? Yeah, it can't be 140, but it also can't be 0 or under. It has to be a positive value, or you're not alive. Okay? So where R is a positive number, and we show it on the graph as we did. Okay? Okay, any questions? Any of it we should go back to?